All right, so using this idea of standard form and graphing using intercepts, we're going to see if we can do the typical story problem that we've been working on this year. A swimming pool is being drained at a rate of 720 gallons per hour. I think we actually had this problem already this year, but we're going to see how to do it a different way. The table shows the amount of gallons left in the pool based on the number of hours the pool has been draining. So here in the table we have the time that has gone by, and then the table's telling you that we're going to use that as our x variable. And then we have the volume that is left in the pool, or the volume that has been drained out of the pool. What is it? The volume left in the pool, that's right, because notice that these numbers are getting smaller. And then they're telling us that that's y. We should, at this point, be able to figure out x and y on our own. We should be able to say that as time goes by, more water is drained out of the pool. Therefore, time is x and water drained out of the pool is y, or the amount of volume left in the pool is y. Okay? That's a skill that you guys have at this point. So they're kind of giving you a little advantage here by doing that. The next thing we need to do is just start answering questions here. What does the 0 in the x column represent? All right, that's right. I mean, we can see that when x is 0, y is 10,080. But what does that mean for this problem? Yes. So when we start draining the pool, there are 10,080 gallons in it. That's what when x equals 0 represents. In terms of algebra, when x is 0, what do we have? I think I heard somebody whisper it. On my graphs, when x is 0, I get what? If I go back to my graphs, when I made x 0, what did I get? The y-intercept. So when I go to graph this guy, when x is 0, I have my y-intercept. Number 2, what does the 0 represent in the y column? That is when the pool is empty. That's right. So the time, how long, or when. Instead of how long, I'm going to put when. When the pool is empty. Because when the y is 0, that's the amount of volume in the pool. And if I have 0 volume in the pool, then I have no water in the pool. So the pool is now empty. In terms of algebra, when y is 0, what do I have on my graph? It's the x-intercept. Yeah. So when y is 0, we have the x-intercept. When x is 0, we have the y-intercept. So they've actually given us both the x-intercept and the y-intercept in this problem, which is all we need to be able to draw a graph. I could come up with an equation. I could put it in slope-intercept form. I could put it in point-slope form. I could put it in standard form, but I don't have to. It doesn't specifically say to make an equation. It just says graph the data. So because of the fact that I already have the x-intercept right, or the y-intercept right here and the x-intercept right here, all I got to do is come up with a scale, figure out where my axes are going to go, and then I can draw in my graph. So on this graph, what should we do first? I see a couple of hand motions saying that we should put our axes where? Lower left corner, because we don't have negative time and we don't have negative volume. That'd be like antimatter, and that's not good. That probably wouldn't work out so well for a swimming pool. Okay, so my axes are in the lower left-hand corner, and what's going to go on the x-axis? Time, which is what units? Hours. So I'm going to write hours here. And on the y-axis, I'm going to write what? Volume of water. So that is gallons of water. That's gallons of water remaining in the pool. So now I need to come up with a scale for my hours axis, my time axis. I gotta have 0 for sure. I gotta have 14 for sure. Got 14 lines, so what should my scale be? By ones. It fits perfectly. 1, 2, 3, 4, here's 5. 6, 7, 8, 9, here's 10. And then there's 14. Now the y-axis is going to be a little bit different. I got to start at 0. I got to show 0 for sure. But I also need to show all the way up to 10,080. Go by thousands? Yeah. This will take me all the way up to 14,000, and that's okay. So I'm going to go by 1,000. 1, 2, 3, 4. There's 5,000. 6, 7, 8, 9. There's 10,000. And then all the way up here is 14,000. So it's tempting to try to figure out how much we're changing by each time and then go by that. But it's really hard if I'm asking you questions along the way, like what about at 3 hours or 3.5 hours or 4.2 hours? It's hard to come up with numbers if you have a scale like that. So pick simple scales on the left or on the y-axis and on the x-axis always, even though it's tempting to go with some weird number to make your dots line up on grids. Okay, so now all we have to do is plot this data. And the best part is, like I said, we already have the x-intercepts and the y-intercepts. So just graph those. 0, 10,080. 0, 10,080. We're going by thousands, a tenth of the way up or so. So there's my dot right about there. And then for my x-intercept, 14, 0. So 14 is all the way over here. 0's on my x-axis. I have my 2 dots. They're really spread out. This is going to be probably a pretty good and accurate graph, so I can go ahead and draw on that line. Notice that my line is going to stop at both ends. I'm not putting arrows at the ends this time because I can't extend out into a negative time, and I can't extend down into a negative volume. So then it says describe what the intercepts mean in this situation. Well, we kind of already did, so let's talk about it one more time. What does this mean right here? When we start emptying the pool, we have, right, okay? So we have to get away from exactly what we see and explain it more to, like, if you're telling your little brother what you're looking at here. He's not going to understand what the heck's going on with that dot. So you got to say, well, this is when we started to drain the pool, we had 10,080 gallons. So in that kind of sense, what does this one right here mean? So I'm going to like say a sentence here. I'm going to start it off for you. It took 14 hours to empty the pool. There you go. So in a sentence, that's what that dot right there says. It took 14 hours to empty the pool. Or the pool was empty after 14 hours of draining it. That's another way you could say it. Okay. So when it says describe what the intercepts mean in this situation, it's trying to get at, do you understand what it is that you just graphed? It's like all of you can graph it, but you need to understand what it means too. Okay, we have to graph the following equations using intercepts. So if I'm graphing using intercepts, as soon as I see that phrase right there, that means I'm going to set up my x and y table. I'm going to plug in 0 for y, and I'm going to plug in 0 for x. So for this one, I plug in 0 for y, and I get 0 here equals -2. What is that? Is that true? Can that ever happen, 0 equals -2? No. Because I got a false statement right here, what can I say about the y-intercept in this equation, or sorry, the x-intercept in this equation? If If I plug 0 in for y, I get the x-intercept, but I got something that was false. So what? So if it's undefined, that means there is no x-intercept. Okay? Because I got a false statement when I was trying to find it. So there is no x-intercept, which means that the graph never does what? Never crosses the x-axis. And the only way that can happen is if the graph is a horizontal line. Y equals -2 is a horizontal line. If I plug 0 in for x, well, okay, there's no x here to plug 0 into, so I just wind up with -2. 0, -2 is on my graph. And because the graph never crosses the x-axis, it must be a horizontal line that goes through -2. So that's my graph. I'm going to do the same thing with x equals 4. I set up my little table. I put a 0 in for y. I put a 0 in for x. If I put a 0 in for y into this equation, what do I get? I put a 0 in for y. There is no y. So I wind up with what for x? 4. So I have 4, 0 on my graph right here. Now if I put in 0 for x, I get 0 here equals 4, which is not true. So therefore, do I have a y-intercept? No. And because I don't have a y-intercept, that means my line never crosses the y-axis, and the only way that can happen is if it's a vertical line. So the vertical line will go through x equals 4. X equals 4, another way you can look at that is saying that no matter what I pick for y, x is always going to be 4. So if I pick y is 2, here's y is 2, then x will be 4, which puts me here. If I pick y is 6, then x will be 4, which puts me there. If I pick y is -5, then x will be 4, which is right there. Every single time I'm getting a dot that lands on this vertical line right here. It's incredibly important that you realize and understand that an equation that is just x equals a number is going to be a vertical line that goes through that number on the x-axis. Just the same as it's incredibly important that you understand that if you have an equation that just says y equals some number, x is not present, then it's as if the slope was 0. 0 times x is 0. The x term disappeared. We have a horizontal line that goes through this number on the y-axis. You got to keep those straight. They come up all the time, and you got to know them. So let's graph these 4 all on the same grid. Go ahead. So for this first one, x equals -4, what kind of line will that be? A vertical line that goes through -4. So I'll use blue for this one. And it's a vertical line that goes through -4. -4 is right there. So I'll draw in a vertical line. For my second one, I'll use red. Y equals 2. What kind of line is that going to be? Horizontal line that goes through 2, which is there. So it's a horizontal line that goes through 2. I should have arrows on the ends of these, but since I'm using my line tool, I'm not going to draw them on. My third one, y equals 6. And I'll use my favorite raspberry color. So it's going to be a horizontal line that goes through 6, which is all the way up here. There's my horizontal line. And the last one, I'll use green because I like green. X equals 1. What kind of line is that going to be? X equals 1 is a vertical line that goes through 1 on the x-axis. So there you go. I should have arrows at the ends of these. Each one of these needs to go all the way through the grid that I'm given. And each one of them should be either straight up and down or completely horizontal. Yeah, I made a little box up here. All right, a media download store. I don't know what that would be. What do you guys use as your media download stores now? iTunes? All right, so iTunes sells songs for $1 each and movies for $12 each. Maybe it's Redbox? Does Redbox sell music? I'd much rather use Redbox than iTunes. So let's pretend that Redbox sells music. All right. You have $60 to spend. Write and graph an equation that describes the items you can purchase. What are 3 combinations of numbers of songs and movies that you can purchase? So we have a bunch of stuff we have to do. It says write and graph an equation. So we need to write it first probably and then go ahead and graph it. What is the first thing that we should do on a problem like this? Anytime we have a story problem, we need to first so the important stuff is like the stuff that we're trying to find, the things that we can change. What's the first thing we're supposed to do in a story problem after we read it? It starts with define. Define your variables. So we need to figure out in this problem what things are changing. The number of songs and the number of movies that you're going to buy. So number of songs. Number of movies. Now this is a little bit different because we've been typically working with dependent and independent variables. And on a problem like this, there really isn't an independent or a dependent variable. You just define the variables, and then you're going to write your equation in standard form. And then from that, you're going to graph it. So I just need to pick a couple letters for songs and movies. You could go with the letters S and M for songs and movies. You could go with the letters X and Y, because we typically use X and Y. You could go with L and B, because those are your initials. It doesn't matter. I'm just going to go with X and Y because I feel not creative right now. The nice thing about picking X and Y here is now that I have X and I have Y written down, I already know exactly what's going on my X-axis and I know exactly what's going on my Y-axis. I don't have to sit there and try to figure it out. So that's why I picked X and Y here. Now that I know how many songs I got and how many movies I got, I need to write my equation. That is what comes from the important information. We have songs for $1 each, movies for $12 each, and we have $60 to spend. And I want to spend all of it because I don't want any leftover money so that otherwise I'd just go to the store and buy some candy or some Nerds or something. I don't want to do that. I want to spend all that money, okay? So I'm going to have an equal sign. And I'm going to buy a certain number of movies and a certain number of songs. And I'm going to have spent $60. Now, how much money did I spend on music? $1 per song. So I'm going to write 1x, because x represents the number of songs. $1 times the number of songs gives me how much I spent on songs. And then plus, because we're also spending money on movies. So 12 times y. $12 per movie that I buy. 12y. That's your equation right there. Notice that it's written in standard form, which is perfectly fine. I could put it in slope-intercept form if I wanted to. It does say graph it, so I could put it in slope-intercept form. But then I'm going to be dealing with a weird slope. And I don't really want to deal with a weird slope. So what I'm going to do instead is graph it using intercepts. Now, go ahead and go to the graph. Where are my axes going to go? Lower left corner again, because I can't have a negative number of songs and I can't have a negative number of movies. What's going to go on the x-axis? Yeah, this one becomes easy because I called x the number of songs. So I'm going to put number of songs here. And like I said, it doesn't really matter. It's not like there's an independent variable and a dependent variable here. We're just putting songs on the x-axis because we happen to call songs x. Okay? The number of songs that I get does not dictate how many movies I buy. So that makes y the number of movies. Okay, so my grid is all set up. Now I'm going to graph this thing, but I'm in standard form. So how do I want to graph it? Use intercepts. To graph using intercepts, what do we do? Okay, so normally we put a scale on here before we graph it, but normally we also have an equation that's ready to be graphed. So we don't even know what numbers to put on there yet, but that's a good thought. So once we get our intercepts, then we'll make our scale. How do I get my intercepts? What do I do? Just like normal, what we did before. Make a table. It's like the easiest table in the world. What do we put in that table? A 0 for y and a 0 for x. The 0 for y gives me my x-intercept, and the 0 for x gives me my y-intercept. Good. And once I have those intercepts, then I'll have a dot here and a dot here somewhere, and then I'll be able to draw on that line. And I don't have to worry about slope or anything. It makes it easy. So I plug in y is 0. So what happens to this term? It's like it goes away. I plug in 0 for y, and I cover up that whole y term. It's gone. And I'm left with what? 1x equals 60. So therefore, x equals 60. I do the same thing for the x term. Plug in 0 for x, and what happens to that term? Yeah, that term disappears, and I'm left with 12y equals 60. Now maybe you can't do that in your head, and that's fine. Divide both sides by 12, and you get y equals 5. So therefore y equals 5. Those are my intercepts. So on the x-axis, what does my scale need to go to? I got to get all the way to 60. I got 14 lines sitting here. By 5s? Okay. So if I go by 5, that's 10, 20, 30, 40, 50, 60. So that does it. I'll label those. Okay, on my y-axis, the number of movies, I got to make it all the way to 5. So by 1s is perfectly fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 14 at the top. So notice that we had to have our intercepts before we could make the scale on our graph. Otherwise, we wouldn't know what numbers to put down. So now what do we do? I couldn't hear you. Yeah, plot those intercepts. So we have 60 comma 0, which goes there. And then we have 0, 5, which goes there. 2 dots is all I need to draw a line. So I can go ahead and draw that line in there. So now this last part, it says, what are 3 combinations of numbers and of songs and movies you can purchase? This gets at the idea that a graph shows me all of the possible solutions to the problem. It shows me all of the ordered pairs that work for the situation that I have. In this case, for the equation that I wrote down. $1 times the number of songs that I got, plus $12 times the number of movies that I got, spends exactly $60. Okay? So, this line represents me spending $60 on songs and movies. I need 3 combinations of numbers of movies and songs that you can purchase and spend exactly $60. So we're looking for where this line exactly crosses, because I can't buy like 1.7 songs. I can't buy 6.2 movies. It has to be whole numbers. So, do we see any places where this actually crosses exactly. I heard 5, and so that would be here. But I go up here and I don't see exactly a nice number there. Oh, 5, so 5 movies and no songs. So 5 movies, 0 songs. That's 1. 50 songs, 1 movie. Does that work? 48 songs and 1 movie. Does that one work? You can always check on your equation. If I go with 50 songs, that's $50, which means I have how much money left? $10. Can I get that 1 movie? No. But if I only got 48 songs, then I'd have $12 left over. So my graph looks like 50, 1 works, but the math shows me that it doesn't. It's actually 48, 1. So that would work. 1 movie, 48 songs. There are lots more. Give me another one. It seems like 25 songs and then 3 movies. But if I get 25 songs, that's $25. $25 from 60 would be $35 left over. If I get 3 movies, that's $36. So actually that one doesn't work. 2 movies would get me to $24, which means I have $36 left over. So 36 songs and 2 movies. What if I got 3 movies? I've used $36 then. That would be how many songs? 24 songs. And then the only one I don't have up here right now is 4 movies, 12 songs. Actually, I do have one more. Zero movies and 60 songs. All of those work. This problem asked for just 3. So just pick 3 of them. And actually, in this problem, we already had 2. We had 60 songs and 0 movies sitting right here. We had 0 songs and 5 movies. So then it was just a matter of finding one more that works. And then you can always check your math in your equation to make sure that you were actually right. We did see a couple, like this one right here, seems like that one works, but it actually doesn't, because the scale makes it a little too small for us to actually get that number. So this is your summary of everything basically that we've learned so far. We have 3 forms of equations. Standard form, which we just learned, point-slope form, which was section 4, and then slope-intercept form, which was section 3. All 3 of these graph the exact same equation. They are the same equation. They're just kind of written a different way. So you can describe any line using one or more of these forms of a linear equation. Any 2 equations for the same line are equivalent. They're the same equation, even though they look different. So we have some information on this graph. The slope is the rise over run. If I go from the left point to the right point, which is what I always do, then I'm going to decide, do I go up or down first? If I go up, that's a positive slope. If I go down, that's a negative slope. And then I'm always going to the right. The y-intercept is where the graph crosses the y-axis. It's an ordered pair. In this case, it would be 0, 6. An ordered pair is x, y. The x-intercept is where the graph crosses the x-axis. In this case, right there. It is an ordered pair also, 9, 0. Slope-intercept form is y equals mx plus b. Point-slope form is y minus y1 equals m times x minus x1. And then standard form is ax plus by equals c. But we have to remember that there's 3 rules on this one. A has to be positive, or that you can't start with a negative number in the equation, and you can't have any fractions or decimals. If you can remember that, then you can remember standard form. So for this particular equation right here, we have a y-intercept of 6 and an x-intercept of 9. This equation right here gives me a y-intercept of 6. If I cover up the 2x, I'm left with 3y equals 18, which means y is 6. If I cover up the 3y, I'm left with 2x equals 18, which means x is 9. So from those two, I get my graph. Or, because of the fact that I have a y-intercept of 6 and a slope that is down to right 3, that's a slope that's negative 2/3, I can write slope-intercept form, negative 2/3 x plus 6, right away. Or, because I know my slope is negative 2/3, and they give me this point right here of 3, 4, then I can write in point slope form y minus the y-coordinate of that point, so y minus 4, equals the negative 2/3 times x minus the x-coordinate for that point, 3. And then if I was to take this and simplify it down to slope-intercept form, I'd wind up with exactly that. If I was to write this equation in slope-intercept form, I'd wind up with exactly that. All three of these equations are exactly the same. If I was to take this equation and put it in standard form, I'd wind up with exactly that. If I was to take this equation and put it in standard form, I'd wind up again with exactly that. All three of these equations are exactly the same. They show exactly the same graph when you graph them.